what we're going to do now is we're going to talk about Android layers and concurrency. So I wouldn't say we're done with all of the Java stuff. There's still a few more Java things we'll cover. We'll cover things like stamp locks, for example, which is a reader's writer lock. But we're going to start morphing ourselves now into a discussion of Android and some of the Android-specific concurrency frameworks and mechanisms. And we'll start off by talking about the architectural layers in Android, and we'll understand the architectural layers with respect to concurrency, which is really the focus of the course. So let's talk about the layers first. So Android's architecture is structured into multiple layers for several reasons. There are a couple of reasons why they do it that way. First of all, you can see that there's a bunch of layers. Each of these different colored rectangles is a different layer of Android. One reason for having layers is to enhance systematic reuse, because that allows us to be able to reuse things that were developed for perhaps some other purpose, right? So the operating system kernel in Android is largely based on the GNU Linux kernel with a few extra things. The Android system libraries are largely based on a bunch of pre-existing libraries, not the least of which is a libc-like library called Bionic, or Bionic, not Bitonic, Bionic. And then there's also stuff, right? There's sort of a virtual machine or execution environment that could be reused, and in fact is reused. There's a bunch of libraries that they have, that Google has shamelessly pilfered from Oracle in terms of the declaring code and some other stuff and so on and so forth. But the point is that a lot of the stuff is reused. This also allows us to kind of plug and play certain things. You could conceivably come along and plug in different hardware, maybe different OS kernel implementations and so on and so forth. That's a motivation for using layers, because you can change things within a layer implementation without necessarily breaking the stuff that lives on top of it. And the effects of these updates, right, if you change things internally, can be confined to the layer implementation and not spread up and percolate through to the upper layers and break application code and so on. That's the concept of plug and play. And another benefit of using layers is it reduces the complexity of the APIs that the application developers must know. By and large, application developers really sort of have to know the application framework layer and a little bit of the layers here that deal with Java and Android concurrency and so on, focusing on the concurrency parts of the discussion here. And they don't really have to know much about anything underneath. So it's about separation of concerns, encapsulation, hiding diversity, hiding heterogeneity, and so on and so forth. This is what's sometimes called the facade pattern. And it also enabled Google to use a bunch of popular APIs and protocols and programming languages. So you'll see Java and C++ and Linux and C and TCP/IP and a bunch of other good stuff here. And they didn't have to go out and develop all that from scratch. In many cases, these popular protocols and APIs are available in open source form. In fact, you can get the source code to Android. You can get the part of Android that's from the green on up to the blue in open source form. And at a different website, you can also get the operating system kernel available in open source form. And there are various reasons why they separated things like that. All right, so that's just, that's Android in 4 minutes. There's a lot more to it, of course, but that's the high-level view. Now let's talk a little bit about the layers, but now let's give it a concurrency perspective. We'll look at it through the lens of concurrency. You could also look at it through many other lenses. Android is very, very interesting and got lots of stuff, but we're going to focus on the concurrency parts. And of course, the idea here from a perspective of Google was to be able to make it possible to run programs in general and concurrent programs in particular on a wide range of computing devices, including smartphones and tablets, and now you can also run it in your browser, on your desktop or your laptop. They've really made it possible to run on all different environments. You can run it in an automobile, in a watch, various wearables, things like that. TV set. The layers here are not uncommon in other Java platform implementations. If you were to look at another version of Java, you would see more or less the same layers. They just wouldn't quite be done in this way. Okay, now why do they do it like this? Well, the whole purpose of having a layered approach and these different levels of abstraction is to balance performance, in other words, how fast things run or how scalable the implementation artifacts are, on one hand, with how productive we can be as human beings writing code. And they're trying to find the right balance. You could write everything in one way, but it might be slow, or you could write everything in another way. It might be fast, but it might be hard to actually program. So Android's trying to strike this balance between programmer productivity and computing performance. The Android Linux kernel controls the hardware and manages the system resources, not the least of which is to manage access to the underlying processing cores. So that's what an OS kernel does for you. It does scheduling of higher level threads and things that run in processes onto the underlying hardware. The libc library that comes in Android's Bionic API basically supports the pthreads C programming APIs. So if you have ever programmed with C, you can program concurrent programs in C using something called POSIX pthreads, which gives you very low-level, tedious, and error-prone mechanisms for spawning a thread and waiting for a thread to finish and so on and so forth. Very efficient in the micro way, but tricky to program, but they're there. You would normally not write code like this unless you were to program with the NDK, the Native Development Kit, or perhaps, unlikely, but perhaps if you were programming with the JNI, the Java Native Interface. There are also other layers. There's the execution environment layer, which is called Dalvik and Art. Art is the Android runtime, and that provides a execution environment, which could be a bit of a virtual machine. It could also be part of sort of a managed code infrastructure. It's a managed execution environment that takes care of things like garbage collection and other aspects of safety of your code, checking to make sure you're not accessing stuff that's out of bounds and not doing things that are protected by the Java programming abstractions and so on. So there's threading stuff there. And there's also, of course, lots of threading stuff here. So the Android runtime layer, that's what this layer is called here, Android runtime, contains things like the Java util concurrent package, which has a lot of the stuff we've talked about, right? Like the Java thread, the various things relating to all the concurrency mechanisms and synchronizers we've talked about, semaphores, reentrant locks, condition objects, stamped locks, cyclic barriers, countdown latches, all that kind of good stuff. Those are all things that they get from Java. And by the way, I should have mentioned this before. One of the things you get out of the execution environment is support for the built-in Java threads and built-in monitor objects. So things like synchronized and wait and notify all, those all come from the virtual machine or execution environment layer. And another thing that you provide, or another thing's provided for you in the Android runtime layer is something related to concurrency frameworks. And we'll see shortly that there's two important frameworks in Android with respect to concurrency. One of them is called the Handlers, Messages, and Runnables framework, or the Hammer framework, and the other is called the Async Task framework. And we'll talk a bit about Hammer, but we'll focus on async tasks because that's what you're doing for the next assignment, and that's got some really cool features in it. And then finally, we've got the application level stuff, which reuses everything that comes underneath it. And so there's not a lot of concurrency provided at this level, but it's leveraging the concurrency frameworks and mechanisms at all the layers that come underneath it. Mostly accessed, of course, through the Android runtime classes. Okay, so that's just a quick top-level, big-picture view of what's going on in Android. I just wanted you to sort of see how it all plays out. We're going to focus on a particular layer, but I wanted you to see that there's many pieces involved in how it all works